Welcome to the video on the Chapter 2 and 3 homework from FEP Geotechnical Engineering. Remember at the end of Chapter 2 there was this series of 6 questions about things that we had discussed in Chapter 2. Rather than going over these and writing these all down on this recording, I'm going to email you a Word document, a PDF, with the answers to this so you can check your answers. But again, remember, I encourage you to go through and see if you can answer these for yourself. You'll recognize that some of these were questions that were multiple choice on your test that was due this week, and I guarantee you that some of these are going to show up on the final exam too. So it's a good exercise to go ahead and go through these, find the answers in your textbook, and be familiar with this information about geotechnical engineering. But what I want to do on this video is go into the Chapter 3 homework and go over how to solve some of those problems. So for our Chapter 3 homework, we're looking at 3 different soil samples that were collected throughout the state. I did a sieve analysis on each sample, and it's provided below how much weight passed through all of these sieves, along with 2 Atterberg limits, the liquid limit and the plastic limit. And your task is to classify each soil type using the AASHTO classification system. So before we start in on this, the first thing we're going to want to do is make sure that you have your important equations and information handout, because you're going to need your table, that very first page table here that has the AASHTO soil classification. We'll need this information once we've gone through these calculations here. But let's go ahead and start off with these calculations. I'm just going to move out these other pages from underneath it. Come back to those in a moment. Okay, so what we're going to need to do is figure out from this retained weight what percent of the total that is, the cumulative percent, and what percent finer we have than that weight. Now remember from physics, I was noticing this when I was looking over this last night, this is calling grams a weight, and remember that grams is actually a mass. But remember we also discussed that people will use that terminology for weight instead of using newtons here for weight, because that's not usually something we refer to. So we're just going to go ahead and call grams weight and go from there. Okay, so what we do is we take the part here, this is 5.1, and we're always going to put our part over total to figure out our percent. So for our first amount that passed this number 4 sieve, 5.1 was retained. That amount did not go through the sieve, and so that's what was left on that sieve out of the total. We just take 5.1 divided by 510. I get 0.01, but remember, I want my answer to be a percent. Okay, that's the decimal form. So in order to change it to the percent, I have to multiply it by 100, and I just get 1. So that is 1%. And then I can see this is going to be the same answer here because it's the same number, so I don't need to do that calculation. 1%, same thing. For this I have 35.7 over 510, so I'll put that into my calculator. 35.7 divided by 510. I get 0.07, again, multiply by 100, 7%. And here note, I'm asking for all these percents and whole numbers. So far that's been pretty easy to do. 214.2 divided by 510, that's 0.42, but remember I have to multiply it by 100 to get the percent, so it's 42%. Let's write all this out here so you'll have that in case you're wondering where these numbers come from. And then my last one is 249.9 over 510. And I'll put that in here, 249.9 divided by 510, and I get 0.49 multiplied by 100, 49%. So that's how I figure out my percent total. And remember, that's the percent of the total amount that was retained on this sieve. So 1% of the sample couldn't make it through the number 4 sieve. Remember, those are 4 openings per inch. and then 1% couldn't make it through the number 10, etc., etc. Okay, now we're going to accumulate this and see how they add up together. So for our first number 4 sieve, as we said, it was just 1% that stayed on that number 4 sieve, that was retained on that 1% of the total. We want to know cumulatively how much stayed on this number 10. So it's 1 plus 1, that's 2% stayed on that number 10 sieve. How much stayed on the number 40? Well, it's the 7% plus the 1 plus 1, or we could say 7% plus 2%, so that's 9%. How much stayed on the number 200? That's 42 plus 7 plus 1 plus 1, or 42 plus 9, which is 51%. And then how much cumulative for the pan? That would just be our total of 100%. Okay, so that cumulative percent, we're just adding up the percent that we had of total and what came before. So by the end for our pan, we're to 100%. And another way to make sure our numbers are correct are to take up this percent total once you've calculated that and make sure that that adds up to 100. So let's just check that real quick. We had the 49 plus 42 plus 7 plus 1 plus 1. Yeah, 100% looks good. And you can even write that down here if you want to, just for completeness. All right, now here's the information that we really need to know. This is our really important column that we're going to use to do our AASHTO classification. If there was a way we could just jump to getting this information, we would, because we're not really going to use this information to classify the soil. However, going through the exercise of getting this information helps us get to this column. You know, from this information here, it's easy to get our percent of total. Then once we have our percent of total, we can use that to figure our cumulative, and our cumulative helps us find the percent finer. Because remember, our percent finer is just 100% minus our cumulative percent. Okay, so in this first number, our cumulative percent is 1, so it's just 100% minus 1%. And so that's 99%. For our number 2 sieve, it's 100% minus 2%, so that's 98%. Our number 40 sieve is 100% minus 9%, so that's 91%. Number 200 sieve, 100% minus 51%, so that's 44%. And if you want to, for completeness, for the pan, it would just be 100% minus 100%, and that's 0. Okay, nothing's finer than the pan because the pan catches everything that is in the sample. And then if you'll remember from our AASHTO classification, the box that we're really interested in is this 200 sieve box. That's usually what we'll use. So that's the thing that we really want to make sure that we have correct. And look, I can already see that I've got an error there because I have 100 minus 51, and that should be 49%. So that's a good one to double check as you're doing your math there. Okay, let's take a look at our AASHTO classification system then. We'll go to our chart here that has all our information. Now a quick shortcut here is to look up at the top of the chart. This says it's a granular material if 35% or less passes the number 200 sieve. And it's a silk clay material if more than 35% passes the number 200 sieve. So before I even start going through my classification, I can look at that number 200 sieve and see what the percent passing through that is, which is also known as the percent finer than that. So in this case, I have 49% that's passing that number 200 sieve. So I know that I have to be on this side of the table for this problem. So I'm going to go ahead and write that down as my first step here. I'll slide this down a little bit. All right, so my first step, I'm going to look at how many passed the number 200 sieve. And in this case, for this sample, it's 49%. So knowing that that's 49%, that's going to rule out that whole left of the table. I'm just going to call it A1. It's A1A, A1B, but I'm just calling it A1 because it's all of the A1s. All of the A2s, A24, A25, A26, A27, they're all ruled out, and A3. Okay, by knowing that, looking at that first data point, I can rule out that whole left-hand side of the table. Okay, my second step, I'm going to look at my Atterberg limits here. I'm just going to choose to start with the liquid limit. It doesn't really matter. You can pick either one. But in this case, my liquid limit is 28%. So I'm going to go back to my chart here and take a look. I know I have to be on this side because I've already ruled out all this stuff. So let's take a look here. I know my liquid limit, and if you want to, grab a ruler here, you can use a ruler to just kind of make sure you're looking at the right line, or you could even draw a line on your table, that's fine too. So my liquid limit is 28%. So I know I can't be an A5 or an A7 because they need a 41% as a minimum, and 28 is less than 41. So that's going to rule out A5 and A7. So let's go ahead and write that down. Because the liquid limit is 28%, that rules out A5 and A7. All right, let's take a look at our last Atterberg limit we were given here. The plastic limit is equal to 9%. But when I go back to look at my table here, I don't actually have a plastic limit on my table. I have a liquid limit and a plasticity index. So I have to convert that plastic limit to a plasticity index. Slide this up a little bit. Remember that my plasticity index is equal to my liquid limit minus my plastic limit. So in this case, my liquid limit's 28%. My plastic limit is 9%, so my plasticity index is going to be 19%. Okay, I'm going to just write that over here. PI is 19% because that's going to be important information for me to be able to figure out, is this an A4 or an A6? So let's take a look at that plasticity index. A4 and A6, that's what I'm left with here. My plasticity index is 19%. So that's going to rule out this A4 because it could only be a 10 for a max. So my soil is going to have to be an A6, and I can see here it's called a clay soil, so I can write that down too. That's the significant constituent material, is a clay soil. So A6 clay soil. So because my PI is 19%, that rules out A4, which leaves me with A6, and like I said, clay soil, which I just read off of that chart. And I'll slide that up so you can see all of that. So for completeness, that's the type of answer I'll be looking for in the final exam, and it's a good practice to do your work like this on the test. You know, you don't have to show me all of these calculations to get your percents. You can if you want to, but when you're picking your soil classification using the AASHTO, it's a good idea to list these steps about what you're ruling out, because it is easy to mix up liquid limit and plastic limit or read the chart a little bit incorrectly. And this kind of gives me some sense of what you were doing and what you were thinking. And for those of you who've taken math and physics, you know that there's always some partial credit to be had. But if you just were, for instance, to write down A4 here with silty soil, I wouldn't know what you were thinking, and I wouldn't be able to give you any partial credit. So writing down your justification here is a good habit to get into, a good practice, and it will be a good way for you to get some more points on the final exam. Of course, you're all going to get it right, so it's not an issue, but just in case, that's a good way to do it. Okay, let's go on. I'm just going to put all these on one recording. So I'm going to get on to sample 2. And let's see, that's pretty good. Okay. So same type of situation here. We're given this sample. We know what this retained weight, aka mass, is in grams. So we're going to find its percent of total. Here's my total. So I'm going to go ahead and do those fractions. This is 45 over 375. I'm going to write them all down first. 3.6 over 375. 71.3 over 375. 86.3 over 375, 168.8 over 375. Okay, so there's all of my fractions, and then I just have to use my calculator to do my division. I note up here that it says whole number. Okay, and I'll go ahead and do that. So 45 divided by 375, 12.12, and I have to multiply by 100, so that's 12%. And then I have 3.6 over 375, 0.0096. I'm going to multiply that by 100. I have, 0.96%, but I want to make it a whole number, so I'm going to call that 1%, round that up. 71.3 divided by 375, etc., times 100. So that's 19% as a whole number. 86.3 divided by 375. I get this, multiply it by 100. So I'll call that 23% as a whole number. And last but not least, 168.8 divided by 375 and multiply by 100. And so that's 45%. Okay, so I want to double check this and make sure that these all add up to 100. Make sure I don't have any math errors there. So I have 12 plus 1 plus 19 plus 23 plus 45. Yeah, and those equal up to 100%, so I'm good to go. Okay, so now I'm ready to find my cumulative percent. Remember, when I start off, my first cumulative percent is just my percent total here because it doesn't have anything to add to. But then I have to continue with that additive relationship. So 12 plus 1%, 13%, 13 plus 19. You can think about it this way, adding it up this way, or adding it up this way. 19 plus 1 plus 12, 32%. 23 plus 19 plus 1 plus 12, 55%. And then 45 plus 23 plus 19 plus 1 plus 12 is 100%. And you can always, do that on the calculator, double check it. I know for me, it's easy to make those little math errors. So it's a good idea to double check. Make sure you've got everything correct. For my percent finer, remember I'm going to subtract from 100. I'll just write that out for the first one here. 100% minus 12%, and that's going to be 88%. And then I'm going to do 100% minus 13% is 87%. 100% minus 32% is 68%. 100% minus 55% is 45%. And then 100% minus 100% is just 0. Sometimes I put little lines in there just to know, okay, I'm done with that. All right, and remember, this is my important box that I'm going to start off with when I do my AASHTO classification. And look, it's another big one. So when I look at my table here, again, it's going to be more than 35% passing that number 200 sieve. In this case, it's 45%. So I'm going to put my rules out on the side here. So my first one with that 45% passing 200 sieve. So I'll say 45%. We can say call it finer. Then number 200. That's going to rule out A1, A2, and A3. Okay, it rules out, remember, that whole left-hand side of the table. All right, for number 2, I'll start with my Atterberg limits here. Let's do the liquid limit first. Again, it doesn't really matter, but liquid limit's 32%. So let's take a look. We're on the right-hand side of the table here. Liquid limit is 32%. So I can't have a 41 min again, so I'm going to have to rule out A5 and A7. This is looking similar to my last one. So I'll write down here, rule out A5, A7, and then my last thing here is my plastic limit is 16%. I know that I can't use that in my table, so I'm just going to go ahead and figure out my plasticity index, which is going to be my liquid limit minus my plastic limit. So it's 32% minus 16%. So my plasticity index is 16%. So my plasticity index is 16%, and I'm left choosing between A4 and A6. Well, A4 has to have 10 as a max, so I have to rule out A4 again like last time. So I'm left with A6. Rule out A4. So for sample 2, I'm going to have A6, and remember that is the clay soil. So this is for sample 2. I've gone through that same kind of process where I filled in my columns here and came up with my soil type using the AASHTO classification. Okay, I'm going to go on to the last one here, sample 3. I'll slide this guy up. Same process again, just a little bit different. Only difference here is I'm asking for this percent of total to 1 decimal place. Okay, so I'm not going to write it all out this time. You don't have to either. When you do it on your test, you just have to fill in all the columns. So I'm just going to use my calculator to get me to my answers. So I've got 12.6. I'm going to divide it by 504, and then I'm going to multiply that by 100. So my first percent of total is 2.5%. 2.5%. All right, let's get to the next one. 37.8 divided by 504 and multiply by 100. That is 7.5%. Then we have 180.6 divided by 504, multiplied by 100, and I get 35.8%. Remember your rounding. When you want to round to the first decimal place, you look beside it and see if that number is 5 or more. If it's not, you just drop all those numbers afterwards. If this was a 5 or higher, I would have to increase that by 1. Let's try the next one. 84 divided by 504, and then we'll multiply that by 100. Here's a good example of what I was just talking about. So in our tenths place, we have a 6, but next door we've got another 6. We're going to have to round that up by 1. So this is 16.7. And then my last one here, 189 divided by 504, and then multiply by 100. I get 37.5%. No rounding necessary. All right, so these are a lot of different types of numbers, so I want to add them up, make sure that this is equal to my 100%. I can start at the bottom, 37.5, since I already have that there, plus 16.7, plus 35.8, plus 7.5, plus 2.5 equals. Excellent, worked. Okay, so there's a good place to double check yourself and to double check your rounding if you're doing something that's to 1 decimal place. Okay, so my cumulative percent, I'm going to go ahead and copy that down because that just goes straight across for the first one. And now I have to add them together, 2.5 plus 7.5. Well, that's going to be 10%. 10% plus 35.8 is 45.8%. 45.8% plus 16.7, might need a calculator to do that one. 45.8 plus 16.7, 62.5%. And then 62.5 plus 37.5, that's just my 100%. Okay. And now my percent finer, I'm going to subtract them from 100. So 100 minus 2.5 is the 97.5%. 100 minus 10% is 90%. 100 minus 45.8, I'm going to do that one here. 100 minus 45.8, 54.2%. 54.2%. 100 minus 62.5 minus 62.5 is 37.5%. That's my number of interest. And then remember, this is just 100 minus 100. You can put a 0 there or just a dash, or leave it blank, up to you. But now I have my numbers, and remember, this is my number of interest that I'm going to start with for my AASHTO classification. The percent finer than that number 200 sieve. How much of that material passed through this guy? How many of those small pieces do I have? And again, if I go to my table, I'm hitting this side again because it's more than 35%. This is, close to 35% now, but it's still more than 35%. So I'm going to be able to rule out all of this good soil here. I'm into the bad side, but that's all right. I need to know what I have. So I'm going to put that, I guess I'll put it right under here. So my first step, I've got 37.5% finer than my number 200. So that's going to rule out, again, my left side of the table, A1, A2, and A3. And then for my second step, I'm going to look at my liquid limit again. This time it's 40%. So again, it's going to be similar to what I've seen before. If it's 40%, well, it could be a 40 max, but it couldn't. Let's take a look here. If it's 40%, yeah, it could be a 40 max, but it couldn't be a 41 min because it's going to be less than 41. So that's going to rule out A5 and A7 again. Rules out A5 and A7. And then my last one, again, I have to calculate that plasticity index since it's not given to me. And I remember that it's the liquid limit minus the plastic limit. It's like the index. It's the amount between those two. That's a way I kind of remember that. So it's 40% minus 21%. In this case, that's 19%. And I'll take a look at my plasticity index on here. 19%, I'm going between, is it A4 or A6? Well, A4 can only be 10 max, and I'm at 19, so it's got to be A6 again. So this is going to, slide this down a little bit. This is going to rule out the A4, and that's going to leave me with A6 for this sample as well, clay soil. Okay, so all of my samples for this are pretty similar. They're all that A6. They all have a similar percent fines than 200. Similar, liquid limits are a little bit different, but they're all getting you to that A6 in the end. And if you go ahead and look on your last page of your homework, you'll see that those are all A6. But this is how you get there. If you got any questions about that, let me know, and I'll be happy to go over it. Good luck on the test. Remember, those are due by Monday at noon. That's all for now.